Hello, ladies and gentlemen. Back again in distance learning land one more time. I think this is going to finish our different uh, solution methods for finding the solution to a system of equations. Today we're looking at the addition and subtraction method. I'm going to first do the addition method, make a quick pause, set up the other problem, and then we'll go ahead and look at the subtraction method. Well, for either the addition or subtraction method to work, the easiest way to do it is if you take a look and inspect before you ever even start the problem, and you happen to see, lo and behold, right here, if we look at the x's, okay, the x's here are both threes. Now, one's a positive 3 and one's a negative 3. And because one's a positive 3 and one is a negative 3, and they're both on the same sides, they don't necessarily have to be on the same side. And I'll show you that with the subtraction method when we get there. But if you ever see the same number attached, whether it's positive or negative, it's more than likely going to be the easiest way to solve it if you have the addition or subtraction method. So look for the same number attached to the x, whether positive or negative. So here, again, I have the negative 3x there and the positive 3x. And so this is going to be a sign, a sure sign. Man, I ought to be thinking about either doing the addition or the subtraction method. So let's go ahead and take a look at the addition method. Again, I could go ahead, I could graph these. I'd have to get into y equals mx plus b form. I've got some big numbers though there. And it also looks like, if I, took the 3x over and then I divided by 7, on this one right here, I'm going to end up with a funky number. 19 divided by 7, that's going to be hard to graph. And so it's not going to be very much fun. So anyway, this, again, anytime you see that 3 and 3 or 7 and 7 for one particular x or y, you want to be thinking, hey, addition or subtraction method. So let's take a look at this guy. So what I would do with this one is I would set it up kind of like an addition problem. And so if I took 3x plus 4y equals 25, and then I had minus 3x plus 7y equals 19, and I just kind of set it up like this was going to be some big addition problem right here. I'm going to add straight down these columns, and that's going to help me solve this. So if I take 3x and negative 3x, those guys go away. I get 0x there, and that's something I don't have to worry about anymore at this point. I'll get there in a minute where I do have to. If I take 4y and 7y and I combine them, I get 11y. I take 25 and I add it to 19 and I get 44. And then to solve for the y, again, I'm going to divide by 11 here, and I'm going to end up with y equals 4. So if I go to, again, my answer, what I'm looking at here is that 4 is going to be my y. Now, what do I have to do? Well, just like the previous two methods, the substitution method and the equal values method, I got to plug that 4 back in and see what it gives me for the x. I can plug it into this one. I can plug it into that one. It really doesn't matter, but I just have to make sure that if I choose this one, I keep that negative 3 in there to go through and do it. So let's go ahead and let's do this first one here, the 3x plus 4y equals 25. So 3x plus 4y equals 25. Again, I'm going to take that 4 for the y and plug it in here. So 3x plus 4 times 4 equals 25. So I get 3x plus 16 equals 25. And then Again, take away 16 both sides. Build your wall if you want to. And I get 3x equals 9. Divide off the 3, divide off the 3, and I get x equals 3. So again, more than likely, if I haven't goofed up, my x should be 3, and my answer should be the 0.34. Again, where these two lines meet is at the 0.34. So what do I want to do? Again, I want to check it. I just found the answer with this one, so I want to check it with the other equation and make sure that that 3, 4 works. If it doesn't, I goofed. If it does, bam, I've got my check, and I know that I have done it correctly. So let's go back here. Negative 3x plus 7y equals 19. Plug in my 3 for x, plug in my 4 for y. So negative 3 times 3 plus 7 times 4, does that equal 19? Negative 3 times 3 is negative 9, plus 7 times 4 is 28. Does that equal 19? In fact, if I take 29 and or 28 and I subtract 9, I do get 19 equals 19. And yes, indeed, that does check out. And the answer is 3, 4. All right, put it on a little pause and we'll come back and take a look at substitution or subtraction, excuse me. All right, so we're back. Now we're going to show the subtraction method to solve the system of equations. Again, I've set up another problem here in the background. The key thing that you're looking for here is this one's set up a little bit differently. The 9y and negative 9y are on opposite sides of the equal sign. That's not a big deal. The key to this problem is that there are two 9y's. Okay. Once you see 9y, 9y, you should be thinking this is an addition or subtraction method way to go about solving this one. And so, again, I'm going to work through it, but basically showing the key here that I've got 9y here, I've got 9y here, and it doesn't matter. One's positive, one's negative, but the fact that there is a 9 and a 9 leads me to think, hey, I got to be doing this through the subtraction or addition method. I'm going to show you why we're going to do this one in the subtraction method once we get it all set up here in just a second. So here we go. We have the 13x minus 9y plus 3. The idea here to solve this one is I got to get the y's on the same side of the equal sign. I could either move this guy over here if I wanted to, or I can take this guy and move it over to the negative 21 if I want to. I'm just for reasons that, I'm a crazy old man. I don't know what you want to say. I'm going to do it on the second one. It doesn't make any difference, but I'm going to do it here on the second one. So I've got 13x equals negative 9y plus 3. Then I'm going to subtract 9y here, so that my x is alone on the left-hand side. And what I end up with here is 5x equals negative 9y minus 21. So I bring that over here. 5x equals negative 9y minus 21. Now, you might be thinking, well, why wouldn't I just add this one? Why does Mr. Wire keep saying I got to do a subtraction method on this? Well, the reason is that I have to do a subtraction is that both of these have the same sign. If you'll remember back to the addition method, the 3x was paired with a negative 3x. And so we could just add those and they would disappear. Well, here, I can't add those because I'm going to get negative 18y. So what I have to do is I have to subtract that. And so to subtract that, I'm just going to put a negative here. And I just have to remember that that negative goes on each one of these terms on the inside. And so some of you might think to, if that's -5, let's just make that -5 there. If that's -9, -9, let's make that +9. And if that's -21, let's make that +21, and then get rid of those parentheses. Now we can treat this basically like an addition method. Okay, now that these guys are opposites of one another, 13x minus 5x is 8x. -9y plus 9y, that's going to give me 0y. And then 3 plus 21 is 24. Again, I don't have to worry about that guy. Divide off 8, and I get x equals 3. So going down here to the answer, x equals 3. And then what's y? Well, again, just like we saw with the addition, like we saw with the substitution, like we saw yesterday with the gosh darn, I can equal values method. What you see there is I've got to plug that x back in and figure it out. Where do I go? Well, I don't like going back into these guys because maybe I messed with them. And so I always like to go back to the original problem, make sure I'm still working off the original stuff. It shouldn't matter if you did it correctly, but I always like going back to the original because the original was the one that was based off of. So I'm going to plug that 3 in for the x here. So I have 13x equals -9y plus 3. Plug in 3 here. So 13 times 3 equals -9y plus 3. I want to get the y by itself. So I'm going to take away 3 from both sides. Well, this is 13 times 3 is 39 minus 3. I kind of skipped a step there, sorry. But that's 39 minus 3, 36 equals -9y. Divide off -9, both sides, and I get y equals -4. Well, again, there's my answer for y, so it should be -4. Now I should be able to take both of those, plug them into the other equation, and I should get that I have the a check that shows me I have the right answer. So 5x plus 9y equals -21. Take the 3, plug it in for x. 5 times 3 plus 9 times -4 for the y. Does that equal -21? 5 times 3 is 15, plus 9 times -4 is -36. Does that equal -21? 15 taken away from 36 is 21. The negative is the bigger of the two numbers. So negative is going to be your answer. -21. 36 minus 15 is 21 equals -21. And you have your check. And kapow, you then know that your answer is correct. So if you have any troubles with either the addition or the subtraction method, I'm not making sense, you're having problems figuring out where you move stuff, whatever it happens to be, email me, tyrick@auhsd.net. Have a great day.